Hello everyone, welcome back to the channel. My name is Teacher Samuel, and today I'm going to go through a particularly difficult NMOS past year exam question. This is regarding two trains crossing a bridge. Now I've heard that many students have had difficulty with this question, so not to worry, today I will explain it step by step so that you can understand better. So this is our question. While train X was crossing a bridge from end A to end B, train Y was crossing the bridge from end B to end A. So if you look at our model over here, this is the starting position. Let's say this is train X at end A and it's traveling to end B. And then let's say this is train Y at end B and it's traveling to end A. They started traveling from their end at the same time, and each of them traveled at the same constant speed along the bridge. They took 12 seconds to meet each other on the bridge. So this is the starting model, and this model represents after 12 seconds where they meet on the bridge. Then each of them took 23 seconds to leave the bridge. So from this point, after 23 seconds, we have this model where both train X and train Y have left the bridge completely. Now, given that the bridge is 492 meters long, what is the total length in meters of train X and train Y? Whoa, you might be thinking this is so stressful. There's so many details and so many models. No worries, we can take this information step by step. And first, what we can do is we can see what information we can get and calculate from the question. So to do that, let's clear up most of the words and make this model bigger. So over here in this model, what information do we have along with the model? Well, from the question, we know the bridge length, which is 492 meters. And what's more, we know that after 12 seconds, they meet on the bridge. So the time taken for the trains to meet on the bridge is 12 seconds, the time to meet up. Now, what can we analyze from this information and the question? Well, first we can consider the distance this train on the left travels from here until the meet-up point. So, the meet-up point being over here, how do we analyze the distance this train on the left travels to over here? Well, we can consider that this train has many positions. The back, many positions in the middle, and the front. So, how do we represent the distance on the model that this left train moves? Well, consider what part of the train is touching the meetup point? The head, the front of the train. So, which position on the starting point should we consider for the train? If you said the front of the train, the head of the train, then very good. Why do we consider the front of the train? Well, because we consider the same position as the position of the train at the meetup point. So since the head of the train is touching the meetup point, we consider the head of the train at the starting point, and so we can represent the distance as this orange arrow over here, from the head of the train to the head of the train at the meetup point. Now, what about the train on the right? We have to do the same. Since the train on the right, the head is also touching the meetup point. So we consider the head of the train at the starting point to the head at the meetup point. So the arrow that is blue can represent the distance this train is traveling. Now, to make this simpler, what we can do is we can add people at the head of the train. So we can add an orange person for the left train and a blue person for the blue, or rather the right train. And so over here, we have converted train to train meetup problem to a person to person meetup problem. Now, let's see what other information we can gather from this first part. So, if we know that the bridge is 492 meters long, and it took the trains 12 seconds to meet up, then let's think. In 1 second, how many meters do both trains travel? We can calculate that by doing 492 divided by 12. And so what is the answer to that? It would be 41 meters per second. Now, what does this value represent? It represents in 1 second how many meters both trains travel. And what do we call that? We call that the sum of speed. Now, let's turn our attention to the second part. From this point until after 23 seconds, when they both leave the bridge completely. Now, what information can we gather from this? Well, what we can gather from this is, over here, the orange person keeps moving in the same direction to this point. Why do we choose this point? That's right. It is the head of the train. Remember, we are still considering the same position. And so, the orange person ends up here. And what about the blue person? The blue person leaves from the meetup point in the same direction, again going left, all the way to the head of the train, the same position. And what do these two arrows represent? These two arrows over here. They are the length of bridge, train X and train Y added together. And how can we calculate this? We have here the sum of speed of both trains. And remember, both trains are traveling at the same speed throughout. Now, what other piece of information do we have? We know that after 23 seconds, they go from this meetup point to their respective ends across the bridge completely. And so how do we calculate the length of bridge and train X and train Y? We take 41 meters per second and multiply by 23 seconds. And so, how long is the bridge plus train X plus train Y? It would be 943 meters. And from this point, how can we get just the length of the train X and train Y? We take 943, of course, and subtract by the bridge length, 492 meters. And so, our final answer is 451 meters. Now that we have answered this successfully, let's go on to our summary. So, in this problem, what we have is two trains crossing a bridge. Now, what is the first thing we considered in this problem? Well, what we considered is we can convert a train crossing train person to a person crossing person problem. And that way, we can make our analysis and calculation look even easier on the model. Now, what's the next thing we consider? We consider the trains meeting up. Now, if we want to consider the trains meeting up, how do we determine the sum of speed? We take the distance sum divided by the time, just as we did in this problem. So, thank you very much for watching today. If you have any questions and you'd like to contact me, you can scan the QR code on the left, or if you'd like to join our P4 study group, you can scan the QR code on the right. Thank you for watching today. Happy studying, and see you in the next video.